I wanted to know more of the specifics about how the Titan submersible was designed and manufactured and its specific features. In the process of researching all of this, I realized that there are many possible failure modes besides the one everyone has decided upon, that the carbon fiber tube had failed. I learned much about the details of construction and design indirectly from a former OceanGate employee. As a mechanical engineer type, I am objectively impressed by the design and thought that went into the construction of the vessel. I won't be going into the minutiae of every little detail, but I will give an overview of the important components using a detailed cross-sectional view of the craft. I am convinced that one of the titanium interface rings debonded from the carbon fiber tube, and I think that you'll see that these rings had several different types of stress imposed on them, so it certainly is a possibility that was the failure mode. Let's start with how the submersible was lifted and launched. Here we can see their launching sequence. There was a launching platform that the submersible was placed on via a crane. Then the platform was lowered to below the surface, after which the submersible was free to launch itself into the deep. This is one of Stockton Rush's major selling points, how the submersible was launched and how that made the experience of the mission specialist better than with a conventional submersible design. Before the submersible could launch, it had to be placed on the launch platform using a crane. So here we encounter our first type and most obvious stress imposed on the interface ring bonds to the carbon fiber tube. There were two lifting points at the top of each ring, which were used to lift it onto the platform. Theoretically, it's okay, but it's only as good as the framework holding everything else together. As we'll see, there are quite a few other things that interface with these rings. I have some new details about the carbon fiber tube construction. According to the former OceanGate employee, it was 100 inches long and 55 inches in diameter, which I assume is the internal diameter. As is by now well known, the carbon fiber was wound unidirectionally around a spandrel to a thickness of 5 inches and then cured for 2 weeks. Apparently it took 660 layers to achieve this. When the carbon fiber was done with the curing process, the titanium interface rings were bonded or glued to the carbon fiber tube. Then the titanium hemispheres were attached to the interface rings. As many have pointed out, two dissimilar materials are being used here. So we have at least one kind of stress imposed on this glue joint, which is repeated cycles of compression of 5,500 plus psi happening between two different types of material. This is the one everyone is focusing on as the mode of failure, the implosion of the carbon fiber tube. I am, however, still not convinced that this is the case. Now, let's take a look at the internal and external systems of the submersible. The internal systems included 3 computers in the rear hemisphere, and an elaborate structure had to be made to house all of these devices. In the disputed transcript, allegedly crackling sounds were heard from the aft. Perhaps the electrical problems they were experiencing was a symptom of water intrusion at that end of the craft. All of the electrical apparatus was at that end of the vessel. The external systems included the thrusters, cameras, communications, tracking, ballast, tanks, 2 very large batteries, and various other things that were all built into a seemingly inadequate frame, which also attached to the rear interface ring. This certainly also imposed some sort of stresses on the glue joint at the rear of the vessel. There is also gravity and ocean currents acting upon every surface of the submersible. There was also a detachable skid frame assembly that could be released from the vessel in case of emergency if everything worked as it should. Apparently there were 4 pins that could be removed hydraulically, and then the skid was supposed to detach from the vessel. Now this skid was also attached to the titanium interface rings. So what happens if it only partially detaches? The transcript implies that this may have been the case. Not an unreasonable scenario, as the place where those parts interface are subject to corrosion after repeated dives. That would certainly put some kind of stress on those interface rings, testing those glue joints. Let's take a look at the cross-sectional view. I derived this from a 3D graphic created by OceanGate. Let's start with the carbon fiber tube. As previously mentioned, it was 100 inches long by 55 inches diameter, 660 layers of unidirectional windings. It appears to me that it was actually about 84 inches long, and the remaining 16 inches was provided by the two titanium interface rings. Here we have the titanium interface rings to which the titanium hemispheres were attached. These were bonded to the carbon fiber tube. The 7-inch thick acrylic viewport was held in place by what appears to be a stainless steel retaining ring which was bolted to the hemisphere. One interesting thing to note is that a lot of condensation could accumulate at the hemispheres in the course of a long dive. These glue joints were subjected not only to water intrusion from the 5,500 psi of water pressure on the exterior of the vessel, but also from the condensation occurring inside. Now, I know this to be the case from a former OceanGate employee, so I found that to be interesting, but it makes sense because you have the titanium hemispheres, which are a metal surface, and then you have the carbon fiber. And apparently the condensation did not like to occur on the carbon fiber, but it liked to occur on the titanium hemispheres. At the bottom of the vessel, we have the detachable skid frame and ballast assembly. These were also attached to the titanium interface rings. Next, we come to the tail cone assembly. There is quite a lot of stuff going on back here. There was a frame created to house several things. This frame also attaches to the rear interface ring. I don't know how much all that stuff weighed, but it had to be a considerable amount of weight. There is what appears to be a carbon fiber superstructure in the tail cone that kind of acts as a spine. There was, I believe, also high pressure air tanks, 2 large batteries, and various other things hidden inside of the exterior tail cone assembly. Large blocks of syntactic foam were hidden at the very rear. Curious to me, as that suggests that the tail may have been heavier than the nose of the submersible, but there could have also been foam inside too. You can clearly see the foam here. It appears there are also some low pressure air tanks to provide lift when ascending. What would happen in the case that the tail cone section became partially detached because of a structural failure? Perhaps in conjunction with other pre-existing factors. How does the electrical wiring get inside from this assembly? That's almost certainly another place where water intrusion could occur. As if we didn't already have enough weight at the rear, let's now add the computers and the elaborate framework created to house them in the rear hemisphere. One video monitor in that wall at the back that everyone has seen by now, but also quite a lot of stuff going on behind it. Inside, there was a deck assembly, a toilet, I believe 4 oxygen tanks, and what appears to be syntactic foam, but it's hard to tell from their picture. There was a liner inside that was capable of doing fancy lighting, and then there was those 2 handles from Camper World that the news outlets love to ridicule. I think you can see that there's quite a lot of weight and things attached to that rear hemisphere interface ring. That is why I believe it's likely that that rear interface ring failed because of several different kinds of stresses being simultaneously imposed on it. The debris that was recovered that I could see suggests that everything blew out of the front end of the submersible when the rear end opened up. When I made my previous video, I wasn't aware of some of these other possibilities that existed, like possible water intrusion from the inside. I believe this tragedy may have never happened if there was also mechanical connections between both of the titanium interface rings, in addition to bonding them to the carbon fiber tube. We may never know exactly how the vessel failed, and we'll probably have to wait a couple of years to find out what their investigation concludes. I get where Stockton Rush was coming from and his vision for OceanGate. I personally don't feel like he was the reckless person that the media has painted him out to be, but I also think he definitely made some mistakes in his design. My point is, in this video, is how many different ways something could fail with this design, and I wonder how much they asked what if when they were designing it.